My guest today is Chris Brenton, a dedicated professional with a passion for simplifying the process of threat hunting. Chris is deeply committed to enhancing cybersecurity knowledge through delivering both free and affordable security training. Alongside this, he plays a crucial role in the development of both open source and commercially accessible threat hunting tools. Whether you're aiming to sharpen your threat hunting skills or looking to establish a robust threat hunting program within your organization, Chris is the go-to expert. Stay tuned as we dive deeper into this journey, and feel free to reach out to him directly to learn more or get involved. Hey, Chris, thanks for being on the show. It's really great to have you here.
Hey, thanks for having me on, Chris. Definitely cool.
To kick things off, do you want to tell us a little bit about your company and what you do there?
Yeah, so Active Countermeasures is a network-based threat hunting company. We maintain a number of open source tools. We have a commercial tool. We do education. We do training. We really try to kind of contribute back to the community. Myself and John Strand, we're the two co-founders. Both of us really enjoy security and have had some really good mentors as we came up through the field. So it's really nice to kind of have the opportunity to kick stuff back. As far as like what I do, I would say my job is probably product owner more than anything. So I have kind of a unique job with that aspect, because when you look at most tools, the product owner's job is to figure out how do we keep eyeballs in the tool as much as possible. And my spin on that is we actually need to do the opposite of that. So when we're creating security tools, my goal is have you in there as little as possible. In other words, something goes off that tells you there's a problem, get in, see what you need to, get all the data you need to in one spot, get back out, move on to your next task type thing.
Yeah, really focusing on the developer user experience in this product.
Yeah, exactly. And recognizing that folks wear many hats. They have a lot to do. No one's going to hire someone just to run your tool. So,
right. I think there's whole careers built on that, actually, but that's another show.
Yep.
Was there anything in particular along the way that inspired you to give so much back, or is that just the general feeling that you got along the way and you're trying to do your part now?
I'd say a lot of it came out of working with Alan Powler, the guy who found SANS. I got in there early when SANS first converted from being a database training company to being a security training company. So I got a lot of time to work with Alan. And Alan's just one of these really cool dudes that are in the background that does a lot of good stuff for the community. Like the whole idea of, we have service pack releases of operating systems. He was the one who drove that within the government. And, you'll be hard pressed to kind of find that documented anyplace. Working with him and just seeing how much he gave back was a lot of what kind of got me into that same mindset.
Oh, that's really great. Yeah, I'm a huge advocate for philanthropy and sharing knowledge. And I think karma, even though it's this sort of spiritual concept, has some application in the real world, and it's more of a networking effect than anything, right?
Well, and I think it's a little bit self-serving too, because there are times that you feel like, oh, hey, I understand that technology, right? Like I was going through this with one of my developers today, like, oh, hey, yeah, no, I understand how sequence numbers work. And then they're like, well, what about this? And now it's, I'm not sure. Let me dig into it a little bit deeper now, because I need to really understand it in order to be able to convey that information to you. So, there's stuff out of both sides. Someone who doesn't know anything about it, you get to help bring them along, but you also get to reinforce that knowledge with yourself too.
Yeah, great points. Okay, so I wanted to talk to you about network threat hunting, and sort of to kick it off for our listeners, can you explain what network threat hunting involves and why it's crucial for modern organizations to actively engage in it?
Oh, happy to. So the concept is, when you look at the security tools today that we have, they tend to kind of fall into one or two buckets. They're either in that let's keep the bad guys off our network bucket. So that might be firewalls, two-factor authentication, hey, everybody bring out your little bingo cards, all those buzzwords, that's all, keeping them off the network. But then we have this other bucket that is, okay, when we know the bad folks are in, we can do incident response, we can do forensics, we can do, PR, we can trigger legal. We've got tools for that as well. What's been missing is, how do we tie those together? How do we very quickly and efficiently figure out our protections have failed? The bad guys are in the network. We need to kick off, incident response forensics and all of that stuff instead. And that's really where network threat hunting falls in. So the goal of network threat hunting is to identify what's been compromised on the network as quickly as possible so that we know we need to go in and respond to that.
Are there specific tools or techniques that you recommend for effective network threat hunting? And how would these tools integrate with the existing security infrastructure? Off the top of my head, I think of stuff like Saracata and what have you.
Yeah. I'm a big believer in behavioral analytics. Network-based intrusion detection has its place, and, endpoint security that goes in and looks for malicious code has its place. But the challenges with both of those is that new stuff comes out all the time. And when part of the concern is the new stuff, you're not going to catch that with that type of thing. I think that actually I can give you a good example. So I'm sure most of us remember Sunburst, right? That happened a couple of years ago. So if you're not familiar, SolarWinds, they're a major company. They do network monitoring for government agencies, military, .coms all over the world. They literally have like tens of thousands of customers. The Russians, we think it was the Russians. We're pretty sure it was the Russians.
I think we're got into their network.
Russians, yeah, they got into their network. They inserted malicious code into their code tree. SolarWinds then went through, digitally signed it, released it to their customers, and what they ended up releasing was a backdoor. So this was a system that was going in and compromising. So if I remember the timeline correctly, they were first detected. If they figured out they first got into SolarWinds network in like March. That code started getting released to customers in about the late July, early August timeframe. And then it was December when FireEye came out and said, hey, so SolarWinds is compromised. we have this thing that we've decided to call Sunburst, and tens of thousands of environments are infected by this. And for most folks, that was the first heads up they got that something was wrong. A lot of the organizations that we work with, because we're doing behavior analytics, we've got 2 open source tools, a commercial tool. They all kind of go at this from a behavior analytics standpoint. What they were able to say was, hey, that SolarWinds server, that's calling out to, like an IP address in Europe that has never done that before. And it's going off every 15 minutes, plus or minus a minute and a half, because, hey, attackers could jitter everything these days. But it's going off about every 15 minutes, and it's never had that behavior to it before. So what our customers were able to do is look at that and say, what's going on here? And the feedback I got from at least a couple of them was they went back to SolarWinds and said, hey, what's going on? And SolarWinds said, oh, yeah, that's not us. It must be something else on your box. So they didn't understand what was going on. But because they recognized this thing had a new behavior to it that had no business need behind it, that allowed them to put firewall rules into place to be able to say, okay, my SolarWinds box is not going to Europe. There's no reason for that. We're going to break that connectivity. Well, then, and again, this was in August when that happened. Now in December, they find out, oh, wait, you're infected with with Sunburst, the same as everybody else. But because those firewall rules were in place, they could never activate that C2 channel and actually get into your network. So, right. Yeah, so for me, that whole big behavior analytics, looking at data over an extended period of time, most tools analyze about 20 minutes. What I push in my classes is you got to be looking at 12 hours minimum, more like 24 hours, just to be able to catch the low and slow stuff like Sunburst.
Yeah, so you're talking about baselining before you start turning on these kind of anomaly detections.
Yes, to some extent, yes. I mean, some of these are known quantities, right? Like, your Windows system is going to create a couple of long connections back to Microsoft. It's going to check for patches. There's some things that are in common with all environments that I think we can go through right off the bat and say, hey, all of that stuff, don't worry about that. But now what you need to kind of go in and look at a baseline on is anything outside of that. And some of it's, kind of a toss-up. We did a threat hunt on a hospital one time, and one of the questions we asked them was, do you run TeamViewer? And they came back and they said, yes, we have TeamViewer running on these 2 servers. Well, we went in and we analyzed the traffic flow, and we found TeamViewer running on about 15 different systems. So in that context, 2 instances of TeamViewer, good, they know it's there. about a dozen instances of TeamViewer were bad. How did it get there? And in one instance, it was, oh my God, this is really bad, because they had, long story short, they had a consulting company they hired to manage one of their internal systems that turned out to be incompetent. They fired them. They ended up in court with them over not wanting to have to pay them. And that company that lost that lawsuit still had access to the back end of their network. Oh, I hate it when that happens. So yeah, those are the type of things that you need to go through and discover as part of a baseline. And then once you filter those out, you're right. Now it's just what's changed. Oh, hey, this box has a new behavior to it that's somewhat suspect. That's something that may be worth going in and taking a look at.
Are there IOCs outside of, like, I guess, so if you get a baseline, you're looking for anomalies. Are there things that are maybe more recognizable without that baselining, like certain IOCs that jump out, that scream compromise, that people might want to look for?
Yeah, anything that calls out on a regular basis that seems to have some jitters involved with it. So, I mentioned with Sunburst, it was calling out every 15 minutes plus or minus a minute and a half. That is indicative of somebody running Cobalt Strike. Cobalt Strike has a beastly function where you can go in and you can say, beacon this often, but vary it by this percentage plus or minus. And if you track how many times are you seeing different time intervals when this thing calls out, what you end up with Cobalt Strike is something that kind of looks like a bell curve, right? It's hitting it because their beastly function isn't as random as they think it is. So effectively what ends up happening is whatever that mean is, that's how many, that's what's getting triggered most of the time. And it's far less frequent. It's doing it at the minute of the max. Anytime I see a bell curve, that just to me says, Cobalt Strike. And, Cobalt Strike is the #1 tool used to create command and control channels by both red teams and malicious hackers. So
still for many years now, from what I understand.
Yeah. It's actually, I get excited when I find a C2 channel that doesn't look like Cobalt Strike. It's like, wow, somebody actually put some time into trying to randomize this data. This is kind of cool. It kind of gets a little bit old hat now. So.
Yeah, and that jitter is like just one example of many, I think, where we see the threat actors trying to make automated things look like humans doing stuff.
Well, it actually goes a little bit deeper than that. So a lot of network-based threat hunting tools are based around an algorithm called Kmeans clustering. So that's K-MEANS space clustering. In case you want to look it up, it's good wiki. There's a good wiki on it. But all Kmeans is it's math. And it's math to say, hey, I'm going to take this large data set, like 1 million connections that went out to the internet from your internal environment today, and I'm going to look for repetitive patterns. So if on one of your systems, you have something that's calling out to, let's say Guangzhou, China, once per minute, well, that's a pattern. Kmeans will flag that. But as soon as you jitter that connection, if you go in and you say, okay, once per minute plus or minus 10%. So now it might be 54 seconds. It might be 1 minute, 6 seconds. It's changing it up a little bit. Kmeans looks at that and says, oh, that's not a repetitive pattern. I'll ignore it. So any technology that's relying on Kmeans, if they can't catch it with Kmeans, well, now they're going to drop back to being signature-based. And as soon as you're signature-based, you can only catch the stuff that you actually know exists. Anything new that's cutting edge, you're going to miss that. So I think that's an awful lot of the reason why we're seeing, honestly, I haven't seen a red team or a malicious channel or a malicious actor not use jitter in at least 4 years. So yeah, it's pretty common today.
Interesting. So one of the things we like to think about a lot at LimaCharlie and the sort of crew of folks that I spend my time with is like automation and scaling. And I'm just wondering if there's ways to automate some of this network threat hunting, or does it still kind of need the human eyeballs to kind of make sense of the signals that are coming through?
I think you need a combination of the two. I know there's a lot of hope that AI will fix what ails us, and I think we're a long ways off from that. I think you still need a combination of the two. You need the automation to kind of help reduce the work. So for example, what I like to do is I'll leverage some automation tools to go in and say, okay, those 1 million connections to the internet, where does it look like there's connection persistency, right? Like if a system connects to an IP address 100 times in like a 30-second period of time, who cares? but it connected 100 times and it's fairly evenly spread out over the course of a day, oh, that's something I want to go in and take a look at. So I think automation is great for saying, let's reduce the amount of work that actually needs to get looked at. And then once you've done that, now it's kind of nice to bring a human in to kind of look at things to say, is there something new here that maybe doesn't look right? A lot of these channels tend to be, there's something a little off that it's hard to identify up front that, that how I want to say this. Okay, so a good one is probably like user agent strings, right? So we know a couple of malicious actors out there have certain user strings we want to look for, and we could go in and try to automate to look for that. But I ran across one about a year and a half ago that the user agent string was a Sinclair 1000. Well, if you kind of look at computer history, Sinclair 1000 came out in, I think it was late 70s, early 80s. It never had an IP stack. It was never on the internet. There's no way a Sinclair 1000 is connecting out to a system. That's something that a human can look at and say, no, that's not right. Something's wrong. And that's hard to kind of program in.
Right. Do you use cyber threat intelligence at all when you do network threat hunting, or is it just strictly behavior is the way to go?
Yeah, I'm not so cyber intelligence was awesome when our threat vector was little Bobby living in mommy and daddy's basement trying to own more systems than, his friends that play the same online game. In other words, back when what we were worried about was mass propagation. And, certainly there's still some of that today. Threat intel makes a lot of sense because it's almost like antivirus, right? Because, with antivirus, Chris, if you and I have the same AV software, I get infected, oops, stinks to be me, but now they write a signature and now you're protected from that. Threat intel is a lot the same type of thing. If we're dealing with mass propagation, it makes sense. When you work money into this and you start seeing that, well, no, the threat actors we're worried about today are crime organizations. They're nation states. They have financial funding. We were talking about Sunburst earlier. I saw an analysis that estimated there was probably close to 100 developers working on the code for Sunburst. There's money behind that. When there's money, all of a sudden, the tactics they use to try and get in are going to get changed. The code they use are going to try and get changed. The source they come from is going to get changed. One of the things that we kind of fight with a lot is we try to make a lot of PCAPs available for different types of attack patterns. So if you go to our blog and you do a lookup on malware of the day, there's always a PCAP you can download that is some specific attack tool, and you can check out, what the command and control channel looks like. Well, the IPs in those are test systems. We're using a public cloud for that. Those IPs keep ending up in, VirusTotal and other sources saying, oh, this host is evil. Don't let anybody talk to that. It's like, no, this was tested in a PCAP. Come on, give me a break. So yeah, I'm not a big threat intel fan these days. I'm more maybe the other way around. I'm more likely to safe list something based on what it is versus think it's malicious because it ends up on some list someplace.
Yeah, you made a couple interesting points along the same line, and that's like, signatures and threat intel are really identifying things that are already out there. So if you're dealing with some kind of novel or high-level intrusion, none of that stuff's going to exist. So you're kind of wasting your resources in a lot of ways.
Yeah, and part of the problem is you don't get a timestamp, right? Like if something told me, oh, hey, this was a threat intel match based on data submitted 12 hours ago. Okay, that's valid to me. Right. What you don't know is, did that IP address show up 6 months ago? And if it did, that's not really that helpful, especially in like a public cloud.
Sure, I did some testing. 40,000 IPs.
Yeah, exactly. Exactly. Yeah, I did some testing of some open source threat intel lists and some commercial ones. I think it was about 6-9 months ago. And what I found was for the commercial lists, about a 20% false positive rate was average. For the open source ones, it was closer to like 80%. Like a majority of the time when it goes off, yeah, it might give you that warm fuzzy feeling like it's doing something. It's not. It caught, one of your salespeople ordering a pizza, and that website just happens to be an IP address that was used for a C2 server 6 months ago.
Yeah. Oh, interesting. Okay, so are there common challenges you encounter in your work network threat hunting? And if there are, what are they? How do you overcome them? And can you share like a study or an example where you successfully navigated these?
So I think the biggest challenge I deal with today is kind of getting people on board with we need to do something different, right? Because SIM's been around for a while and it's part of every security attestation, right? Every security framework has a requirement in there that, hey, send all your logs to a central place and, look for malicious activity, whatever that means. And that's not working. And it hasn't been. When you look at the data that comes out of like Mandy and Verizon, these companies that are being brought in as part of IR, there's a trend you'll notice, which is the amount of time it takes between when a system gets compromised and when we catch it really isn't changing. It's still out in the 3 to 6 month range. When the number is less than that, you'll notice that they've started including ransomware as part of the numbers. And ransomware going off is identified as positive detect, which to me is just laughable, right?
Yeah.
Imagine someone breaks into your house, steals all your electronics, and and then they show up at your front door the next morning and say, "Hi, it was me who stole all your stuff." Are you going to go on social media and say, "Wow, the cops in my town, really good. They found the attacker who stole all my electronics by, within 12 hours." No, of course you're not going to do that. Well, that's what we're doing when we include ransomware into those metrics. So getting folks to recognize that. The other metric that kind of parallels what I'm saying is even if it looks like we're detecting things faster, when you look at what does it take to recover? How much effort is involved? How much money gets spent? That's the same. That isn't changing. So that to me says, yeah, even if the first number looks better, the second number says it maybe isn't. So getting folks to kind of realize that this trying to find the bad guys in your SIM probably isn't working, and maybe we need to try something different. And, maybe it's network threat hunting. Maybe it's something, I haven't thought of yet. That's fine. But we need to do something different. I think we've got a little bit of that, what's it called, sunk cost fallacy at play here, where it's, well, we bought this thing, we paid a lot of money for it, we hired people to manage it, and it's not really working, but we've got so much invested, we just got to move forward. Well, no, that's the wrong way to go in and look at that. So I think that, to me, is probably one of my biggest challenges today.
Yeah, and I think when you mentioned those two numbers, I think the first number might be indicative of more low-skilled threat actors just throwing their hat in the ring and getting caught by the simple tools.
Yeah.
Interesting. Yeah, so when we talk about like nation state actors and people who kind of go low and slow, new IPs, new techniques, new signatures and stuff, how do you go about identifying those? I imagine the behavioral stuff isn't going to catch somebody who's moving slow across, months, if not years.
So there's when you talk about command and control channels, there's a balancing act, right? There's a balancing act between I can have it go off very fast, but by go off very fast, what I mean is when a system gets compromised, it'll start calling out to a command and control server. And that connection is how the attacker reverses in and takes control over that system. So if it calls out to the command and control server very frequently, let's say once per second, it's a very responsive system, but now there's an outbound session taking place once per second, and the local folks might actually recognize that. So the idea for the attackers is slow it down. Right? We talked about sunburst going off every 15 minutes. That's a great example. A connection going off every 15 minutes. If you're just looking at packets going by, you'll never notice that. But there's a balancing act to it, which is how responsive is that system? One of the things I think we miss sometimes is that a lot of these nation states and malicious actors are run like legitimate businesses. So imagine your boss coming to you and say, "Hey, I need you to go, run this command or find this information." If you were to say to them, "Well, can't do it for 3 days because that's how long it's going to take before it calls back in," they're going to be pissed, right? Yeah. They want an answer now. So how slow can we go before it really kind of comes up non-functional? And, I think sunburst is a great example of that. That's the slowest we've seen so far. So if you can detect something going off in that every 15 to 20 minute time interval, you're in pretty good shape.
You've caught most of it, yeah. I just think about like the XZ utils, the attempted compromise of that open source project recently. I'm not sure if you're familiar, but threat actors spent years building credibility and making commits just so that they could get the trust to get something committed into the several main branches of the Linux kernel, which is...
and it was really kind of an accident it got caught at all. You know,
Totally.
It was someone who was not a security researcher that, hey, this is not testing right. Because otherwise, it would have been in there. Yeah, and, you know, that's a great example. And that's, you know, so we're seeing that with some of our perimeter hardware right now, too. You know, Cisco's got an advisory out saying, hey, if you're running an ASA firewall, oops, you might be compromised. And because it's on the edge of your perimeter, it's kind of hard to see if it's compromised or not. So, hey, we're going to, you know, send you some patches and hope for the best. So,
yeah, I actually read one of their advisories the other day that kind of left me baffled. It was, we've noticed an uptick in brute force attacks against all these perimeter devices. We can't attribute it to anybody, and they don't seem to be targeting any industry. And I was just kind of scratching my head. Well, what was the point of that? Because
yeah, exactly.
I feel like we should assume they're being attacked all the time.
Yeah, you didn't tell me who it was, why, or how to find them.
Yeah.
That wasn't helpful. Yeah.
Just some fear. Here's some fear.
Yeah, exactly. Well, you know, that's it. We're worried you didn't have enough to worry about already. So, hey, remember us?
And they're going to have a subsidiary selling anxiety medication soon.
There you go.
Yeah. All right. So looking forward, what trends do you see shaping the future of network threat hunting? How should organizations prepare to meet these evolving threats?
So, yeah. Gee, this is a big one. Because that's kind of that. I think we can count on some consistency as far as nation states are not going to stop what they're doing. These criminal organizations that are, let's say, beyond the reach of the law, right? Because, you know, we know there are crime organizations working out of Russia that basically have a gentleman's agreement that says, hey, so long as you don't attack Russian assets, you know, go do what you want, but we're going to tax you on the money you bring in.
Yeah.
Which I think is just awesome. I think that type of stuff is going to continue. You know, as far as what techniques are they going to use? Again, you got to think of it like a business. You know, they're going to handle it the same way a business is, which is what's getting us caught? What's preventing us from getting access to that resource the most? That's what we're going to go and focus resources on. And what that's going to be, honestly, kind of changes over time. What's kind of nice about going after the network is everybody tends to kind of ignore that. They're more worried about code execution and is it detectable by the kernel, and, you know, and everybody's kind of focused on that, which is kind of nice because, you know, packets are packets. They can be coming from a Sinclair 1000, or they can be coming from a Windows box or a Linux. How you threat hunt that, how you go looking for indicators of compromise, it's the same across the board. You don't have to change up your techniques based on the platform.
Right. And like they have to go through the network.
Yes, exactly.
There's no hiding.
Exactly.
There's no going around it. Yeah.
Yeah.
So for anybody listening that's interested in this area of cybersecurity, what's a good way to start learning and maybe acquiring some of the skills that might help them land a job doing this kind of work?
So I am really big on, I'm big on a couple of things. One is make sure it's a passion. I see folks that are like, oh, what will pay me the most? No, because then it's going to be work, then it's going to be a job. You know, I will frequently say that if I made less than a McDonald's line worker, I would still be doing this job because I just love what I do.
Yeah.
I'd still be teaching and still be trying to, help get us better tools. It's a passion for me. So figure out what's your passion and go for that because it will never be work. Now, if that happens to be, network threat hunting, awesome. We need more people in this field. I have a class, it's free, that's available off of the website. We run it live about every 6 months. I think we've had 35,000 people go through that training at this point.
Wow.
But it's a great way to kind of get a handle on what are the basics of threat hunting. Why is it about half the class is lecture and half the class is you download a VM and there's hands-on labs for you to go through and do. That would be a good starting point for you. I'm also a really big proponent on set up a home lab. And it's kind of funny because I see that less now than I did, 20 years ago. 20 years ago, everybody had a home lab to play in. And now, and maybe a lot of it's just because we got public cloud, folks aren't doing it as often. So here's the thing, if you go to your boss and you say, oh, hey, I want to install this device and I want to capture packets and look at things. If you crash the network at work, you might lose your job. Yeah. If you crash the network at home, well, anyone impacted is, related to you, married to you, or friends with you. Yeah, they got to kind of deal with that. So you get a lot more freedom to be able to go through and play with some cool tools. That's where I recommend folks go in and start with first and understand what's going on in your network. Traffic patterns in a business environment might be slightly different, but that process of figuring out, hey, my TV is calling out, every 2 minutes to this address. What is that address? What's the purpose behind this? What type of data is getting transferred as part of it? The process of that is directly applicable to what you do in a commercial environment as well. So get a home lab up and go.
I love that advice. I've been building towers of power for the last 20 years since I went to the school. Just something about the blinking lights that I find so comforting, right?
Yeah. Well, there was a time in my life that I actually had a rack in my office, with one pizza boxes in it. And now they're, it's kind of cool. They're all about this big. They're just little sisters. And you can even run a bunch of VMs on each. But yeah, it's a lot more accessible than it used to be.
Yeah, we actually just got our EDR running for the ARM architecture for the Raspberry Pi. So I've got one of those running at home, and I've got some.
Nice.
I want to build some detections for my garden. I do some watering stuff with the Raspberry Pis in my garden. So.
Oh, it's so good.
The awesome. Soil's dry, fire detection. Maybe turn on a hue light or something. Yeah.
Yes. Yeah, and you don't want it to end up like what was the last IoT thing getting whacked? Oh, toothbrushes.
Yes.
Right. We found out toothbrushes are participating in DDoS attacks now. We don't want our garden watering equipment doing the same thing.
I hate to pop the bubble for you, but that was actually a translation error. So we covered that on the podcast in one of our Intel chats. It was, I think, a German journalist who kind of misunderstood the person was giving like a potential scenario, and then it got published as actual. And then the community, okay. I was actually a little disappointed that it was such a sensational headline that people who should know better about sharing disinformation just went wild and shared enough disinformation that it kind of became, credible.
Well, so if it makes you feel any better, go back to, I think it was 2016. There was a major outage where like half the internet went down on the East Coast, Europe went down. And, that's when most of us found out about this little company called Dyn that was running DNS for like half the internet. Microsoft, Amazon, all these companies were involved. Only I already knew about them. I was working with them. And what happened was they got hit with a DDoS attack. And as part of that, I was able to go through and look at some traces. And one of the things I have a ball with is passive fingerprinting. So passive fingerprinting is you look at like a TCP SYN packet, and there are little nuances in it you can go looking for that'll help you identify one operating system versus another. And, damn if these things weren't, fingerprinting is like Ring doorbells, thermostats. There were IoT devices that were taking place as part of that DDoS. So it might not be toothbrushes yet, but we are well established on that path already, dude.
When I went to research that story because it was so sensational, I did find somebody running Doom on a pregnancy test because I couldn't believe that toothbrushes ran Java. That led down a whole rabbit hole. And so, yeah, I love the internet.
Operating system unless we can run Doom on it. Yes.
Yeah, that's right. Yeah, I love the internet, and I love the people that get obsessed and do things like that. It makes for
one of my favorite all-time tools was Snortbot. So Snortbot was an integration for Team Fortress, where you could have one of the NPC characters in it read your snort logs to you. But the idea was you had to hunt them down and kill them. So I remember I was actually one of the first MSPs in the country at the time that I was running. And I walked in and all my analysts are playing Team Fortress. And I'm like, geez, I pay you folks how much? And this is what you're doing. And one of my analysts says to me, oh no, I'm checking the snort logs. And I'm like, don't bullshit me. I don't have corny here. And she's like, no, really, check it out. And she like, she's a sniper character and sees this thing off in the distance and shoots it. And it's like, kills it. It's like, oh, I love you attack from this IP address here. It's like, oh my God, this is awesome.
That's gamification brought to the next level, right?
Exactly. Hey, this job gets stressful. You got to have some fun with it. So.
That's right. Okay, so for security teams looking to start to improve their network threat hunting capabilities, are there common pitfalls they should look to avoid? Any advice?
So one of the ones that I think is a pitfall right now is the whole, come up with a scenario and then go after it. And what I worry about with that is we tend to have bias selection. Right? Like I was in an environment where we were talking about doing incident response testing. And they're like, oh, we do incident response testing all the time. And when, I kind of looked at what incident response testing, what they were doing, it was always DDoS. Every single time it was DDoS because they knew they were good at that. They didn't look at, well, gee, what if this system gets compromised? So my concern with saying, I'm going to come up with a hypothesis and then run that down is you're imagining that you are always going to be as smart as every attacker out there, and everything you can think of will fit in the bubble of the only things they can do. You got to be open to the inventor. Like I said, I never would have come up with a hypothesis of, I'm going to go look and see if anybody's using a user agent string of a Sinclair 1000. Oh, look, it paid off. You got to kind of stay open. Sometimes they get creative. So.
Yeah, I love that example, by the way. I wish I still had my old Apple IIe. I kept it till about 2005, 2006, and finally got rid of it. And now I'm kicking myself. So.
Oh, awesome.
Yeah. Awesome. Okay. So the last one I have for you, it's the one I ask of everybody that comes on the show. It can be as wide or as narrow as you want. Do you have any predictions for the future of cybersecurity?
Yeah, we're all going to be employed for a long time. This problem isn't going away anytime soon, and it will change. I think the problems from AI are just starting. AI, machine learning, AI isn't real, but whatever. People call it AI, so okay, that's fine. So long as we recognize AI doesn't actually exist, it's just a marketing term like next-gen firewall, then that's okay. But I think, using that on the attacker side to try and help adapt to defenses is definitely going to be a thing. I think we're going to continue to try to use it for defense. But I think we need better tooling before we get there. I was playing around with some AI systems to look at how good are they at collecting malicious traffic patterns. And they actually started getting really good. And when I went in to start, so one of the things you have to do is when AI says, hey, I'm doing well at this, I'm doing well at the task you want, you still have to pull back and say to yourself, okay, why? Is it actually doing the right thing? And when I went in and did some testing, I figured out it realized, oh, hey, anytime there's a command and control server, it's always in DigitalOcean's environment because that was the environment I was using to set that up. So it had learned anything going to DigitalOcean must be evil. Let me flag that. No. So I think we need better tools to beyond just systematic testing to figure out when these things are not learning the data we want them to learn. And that's going to be a big thing going forward too.
Yeah,
and not just in our field. I mean, it's tuberculosis, the detection. They had the same types of problems. So it's in that industry in general. The better tools are needed.
Awesome. Well, thanks so much for being on the show today, Chris. It was a fun conversation, and maybe we'll get to chat again in the future.
Sounds good. Take care, Chris. Thank you so much. Appreciate your time.